then?
Yeah, welcome to the presentation of my final thesis project. This picture is like a small teaser of what is about to come. And the topic is the development of a wood-based modular furniture system. So first I will just guide you a bit through the structure. So I have like everything with a white background like here. It's like the basic, like the common thread, like the main theme of the presentation. Then I have three more topics that I will cover a bit. With the yellow background, I will talk a bit about lean thinking in product development. The green background is about materials, and then I also have a small ethical discussions indicated by the red background. You will notice that later. So let's start. So why this project? What's the reason for it? So I started basically with the thinking, in my opinion, there's something wrong a bit with furniture nowadays. Like, you have low quality furniture, which is affordable. Like, let's say IKEA. I mean, it's not like really super bad quality, but it's not particularly robust. And if you assemble it and want to disassemble it again, then yeah, maybe it's already damaged and you can't really use it again. So yeah, it's a bit not so good in my opinion. And then on the other extreme, you have really high quality furniture, but that is also really expensive. So not many people can afford it. And in many cases, it's actually not possible to disassemble it at all. So once you got it, it's really hard to move to another place because it's heavy and big. So there's a problem. But then in recent years, modular furniture came up, like this one. This is by a company called Movisi. Yeah, and it has standardized parts. You can build up different kind of things. So it's not like super cheap, but you get decent quality for like a kind of reasonable price. So it's like a middle ground between like cheap and expensive furniture. But then, is it really that flexible? I mean, yeah, you can expand it and make like a bigger bookshelf. And if you take one element out and put it the other way, you can like sit on it. But you're kind of limited in the way how you can build up things. So it's not like perfectly flexible. And then last September, October it was, I found the model system. And that's basically just wooden boards like you see and aluminum connectors. And you can just connect them by using your hands. You don't need any tools and you can build together many different things. Like this desk, for example, here you see the connector, or this bookshelf. You can build laptop stands. I have some ideas how to build up a sofa, assemble a sofa out of it. So you have really many possibilities. So I mean, that sounds pretty awesome, doesn't it? Well, there are some concerns, I think, and that's the use of aluminium for the connectors. Because it's not really that eco-friendly, I believe. I mean, you can recycle aluminium, but it still takes a lot of energy to produce aluminium parts, and that's not so good, I think. And then, is it beautiful? Yeah, it kind of is. It looks nice, but it's also a bit like sterile and clinical, maybe. And I mean, it looks like this, so you don't have much variation, or if you want to customize the product even further. And then it's also obviously the cost as well. It's also quite expensive raw material. So maybe it's also not the best solution in that case. And if you can't produce it in a really large scale, then you also need to use quite expensive manufacturing processes. So what can be the solution? Wood, of course. So it's certainly much more eco-friendly. I mean, it's carbon neutral basically. It's quite easy to process, so that way you don't need so much energy. And then I think we can all agree that wood can look quite beautiful, and you have many different wood species. You can make many different surface finishes and treatments, so you can get a high variation of appearances out of wood, which is a good thing as well. As I said before, if you want to customize the product even more. And I think it can be cheaper as well, or at least not more expensive than the use of aluminium. But what's the challenge? That's to keep the strengths, or like connectors that are still strong enough, like the aluminium connectors, without compromising the design. So that was basically the main challenge of this project. And also the main objective of this project was to improve this Modus furniture system in a way that I can use wood-based materials only without compromising the design and keeping a sufficient strength. So before we really dive into the process of developing this product, I will tell a bit about lean thinking, because I think it helped me a lot to keep this project on track and finish it on time. So lean thinking in manufacturing, we had the course with Michael, all the master students. It's quite easy. It's about eliminating waste. It's quite easy to understand how lean works in manufacturing, but how is it in product development? And yeah, it's pretty much straightforward as well. It's important to know what value is, and basically value can be seen as usable knowledge that you acquire and use during the product development process, so that at the end you have a design of a product that fulfills customer needs or has value from the perspective of the customer. So now about some theory about lean. I have this book from Rob Westrick and Chris Cooper, Winning by Design. I think that was really helpful for me. And they present this concept of exploration and execution in the product development process. So exploration, that's basically when you learn things that you need to know to develop the product, when you find solutions to the problems and you generate concepts and select the best concepts, and then at the end you end up with one concept that you want to develop further to a product. And then the execution phase comes in. That's basically the implementation of the design, to make like shop drawings and test the production and stuff like that. And I realized that the exploration phase is definitely much bigger than the execution phase. But according to the authors of the book, many companies, they think it's different, and then because of that they run into problems. And then you have the promise point. That's the moment when like a company would basically announce a product to the public and say like, okay, the product can do that and can do that, so it makes promises. And if they put this moment too early in the exploration phase, when there are so many uncertainties, then they also run into problems, because it's they can't keep the promises that like they did. So I think it's important to have this promise point when you finish the exploration phase. So when you have like a finished design, you can say, okay, we are able to deliver. And then, important thing about lean is to favor decisions over tasks. We learned a bit in our first project planning courses, okay, you have to make like divide your project into different tasks you have to do. But according to lean, it's better to focus on decisions, because it's a more natural way to measure progress of the project. Because that's what you need to do. You have to make decisions. You have to decide on one design or one material. And tasks can be a bit deceiving. You can work a lot on them, but you don't really see how the project is going. So decisions can be a bit more helpful. I think they were helpful to me in this project. And you have this decision flow method that you can use. And that's basically just listing all the decisions you need to make until you have basically a finished design. And then on the left you write down all the learning you need to be able to make a profound decision, and then of course like some kind of output to measure if the decision was really made, like some kind of milestone. You can see it like that. And I think the good thing with this, the left part of the learning is based on the decisions you basically pull knowledge, you pull learning instead of pushing it, like it is not done according to lean. Then if you push knowledge, you think, oh, I need to learn this, and you read a lot, and then later you find out, oh, I don't need all this knowledge, or I need more knowledge that I didn't read before. But if you can pull knowledge based on decisions you know you need to make, then you only do research about the stuff you really need to know. Yeah, that's basically about lean, what I want to tell in this presentation. Of course, there's much more to read. I think it's a really nice book. So now we focus on Noto Fusey. That's how I called the product. It's like a short form for No Tools Furniture System. Maybe I will change it later on, but so far I like it. And and I also kept it in the report, so you know what I'm talking about. So at first I started with determining the customer needs, and I used different methods like the house of quality, the objective tree method. I did the interview at the company North Kingdom here in Skellefteå, and that was quite helpful. Then I found out that actually people are interested in having such a furniture system which is made completely out of wood instead of using metal, for example. And then I also used the Kano model, which is like a method to group customer needs into different categories. For example, you have performance needs. They basically tell, they basically tell how important the needs are for the customers. So a performance need, for example, the more you fulfill it, the more satisfied the customer will be. A basic need, for example, if you don't fulfill it, the customer will be really angry. But if you fulfill this need, he's like, yeah, it's okay, I did expect it, but it's nothing special. But then you have delighter needs. The customer doesn't really know that they have them. So if you don't fulfill them, it's like, yeah, no problem, I don't know about them anyway. But if you can fulfill them, then they will be really delighted and like, oh my god, this is awesome, I need to buy this product. And I think those delighter needs are quite important for this product in particular. And I think the two most important ones are that you can have multiple assemblies of the product. So you can assemble it, then you think, oh, I want to build up something different with the parts. And yeah, just take it down and build something new, and you can do this many, many times without destroying or damaging the product. And the other important delighter is that you don't need any tools to do it. Just your hands and a bit of your fantasy. I mean, it's basically like Lego. And then based on those delighters, it was possible to determine the product specifications. That's basically measurable, like a measurable translation of the customer needs into like stuff like, it needs to be that strong, it needs to be able to handle a load of like, let's say 100 kilos. And then based on the specifications, I could generate all those different concepts that are sketched here. There were 17 in total. And I also used these concepts to pull knowledge or to pull learning. So when I knew, okay, I want to use like a special wood-based material for one concept, or a special way of shaping the geometry, then I was reading about it based on that, instead of reading something before which I might not need after all. And I was using different methods to create all these concepts, TRIS, brainstorming, and morphological charts. I don't talk too much about it, only a bit about TRIS. And that's also kind of like a lean-ish method, which is based on the assumption that all problems have already been solved in a generic way, basically. You just need to apply it into your case. But it goes further than that. I think what's really powerful thinking within this methodology of TRIS is to think of contradictions and extremes. Let's take an example of the MP3 player. Before you had like this Discman devices where you can put like a CD and you can carry it around. And imagine you want to improve this product. Think of the extreme would be, what do you want to have? Like maximum storage capacity with minimal size. So how can you achieve that? You take the CD away completely. So then you have this kind of contradiction you solve by really taking it to the extreme, to taking one component completely away. And then you use the MP3 format, and then you can have a small player. That's like the way how a TRIS can work. And it helped a lot to generate a few of the concepts you see here. So after I did all that and I couldn't come up with more concepts, then it was time to select. And I think that it's important not to select one concept in the first stage, but maybe select 4 or 5, develop them a bit further, and then when you know more about them, then you can make another selection stage, and then you narrow it down in many iterations, or not many, but a few iterations down to the final concept. And in the first stage I used the Pew analysis. I don't know if you heard about it before. It's quite a simple method. You start with concept alternatives listed in the top. Then you have assessment criteria on the left. And then basically what you do, you assess every concept alternative according to all the criteria. And then in the bottom, you find out in the results, okay, those concepts, they're not so good, and those I want to keep. And I had the impression when I was reading a lot about concept selection methods that all of them basically work in this way. Some are using more complex assessment scales, or they use weighted criteria, others just use simple criteria. But after all, at the end of the day, it's basically all like this in a way. But to be sure that I make a good decision, I was running this view analysis in 3 different ways with different assessment scales and different types of criteria to see how the results are affected, and I can really make a profound or sound decision to eventually narrow down all the concepts to those. This was probably the nicest looking ones. This is a bit like the original model system, only with some more material in the middle to make it more stable. This is basically like the original model system, and this one is basically like that one, only more bulky and therefore more stable. And then there's another one like this. It's basically like the second one, but it's designed to be made out of 3 pieces of solid wood, and they're all connected in a way that the grain runs always like in the direction of the how you connect the parts, so you get the ideal strength out of it. So then based off those, or with those 5 concepts, I made finite element analysis, and I programmed it in a way that the material is actually isotropic, even though wood is not isotropic. But the goal was to find out which geometry is the most stable one, regardless of the material I used. And of those concepts I presented before, basically those 2 remained. The other ones were too weak or deformed too much under load. And I also made, to the 5th concept, I made this change. I put some more material in those corners to increase the strength, and after this kind of like adjustment to the geometry, I tested it again with the FEA and found out, okay, it's probably strong enough as well and doesn't deform too much. Okay, now we come to materials. Now that the geometry is basically tested and kind of determined in which direction the concepts will go. And for the materials, I did a lot of literature research at first. Like kind of superficial, only to see like, okay, what's out there, what can be used maybe. And then when I found something interesting, I was like, maybe I read some more about it and see if it might be useful for this product. So then I had like materials like compressed wood, different kinds of plywoods, then this self-bonding wood that Carmen invented or developed, all different kinds of stuff. And for this concept with the solid wood, I used my wood selection tool that I developed before, and then I basically could identify 20 different wood species that might be suitable. And of those 20, I actually bought some Kumaru, it's called, because it's available here in Skellefteå quite easily. And I used that for some tests that I did afterwards. So here you see some results from some sample production. I think this is compressed plywood with melamine formaldehyde glue. And I think I was a bit too aggressive with the pressing parameters. So when I released the pressure, it basically exploded. But overall, it went quite well. That was like one of the few things that went wrong. Then with all the specimens, I had like, I think 15 different types of specimens. I did 3-point bending tests to assess the strengths, and then I came up with those results. So it showed that birch plywood is actually quite strong, stronger than beech plywood. That was the other alternative I tested regarding plywood. Then I call it Carmen wood. It's like the self-bonding plywood. I think it's, why not? She developed it, so I think it's a good name. That's maybe for now a bit risky to use because I think it's not developed till the end. But if it's really like under control, also the process, I think it's a really interesting material that might be suitable for my product as well. Yeah, and then of course Kymaru, the solid wood species I tested, was also really strong. I mean, it's a really dense wood. I can maybe, yeah, I can show it through. It's close to the density of water, so it's quite heavy. And then regarding adhesives, I tested soybean glue. That one company was so nice to send me for free, and also polyurethane glue as some more eco-friendly alternatives to all those formaldehyde emitting adhesives. And it showed that both of those glues are actually strong enough. I never had failure in the glue line, always in the wood. So I think I can use both of those types of adhesives. Okay, now I have a good idea about all the materials. I have a good idea about the concepts. So it was time to make prototypes. And I used this small CNC routing machine that you see here. It's small, but it worked quite well. It was a bit slow, but at least it produced nice prototypes. And I tested also a copy sending process and using like a table router, but that didn't really work so well, especially with the Kymaru solid wood because it's quite difficult to process. That was much easier with the CNC routing. And then I was producing some prototype connectors. Here you see the one out of Kymaru. I also can show that around. And another one. Two more out of different types of birch plywood with different veneer thicknesses. Yeah, and then I made like a test setup for the for the bending machine, and did also like 3-point bending tests. Not really after the standard, but that was not possible with the setup. And you see there's quite much deformation in those boards. And the connectors, they were quite strong. But they had a lot of stress because those boards were bending a lot, and then you have like really high deformation. So I made another test with Kymaru boards that are much more stable and stiff. And then the whole setup broke at around 900 Newton load. I think that's quite much, because I only used 2 connectors instead of 4, which you would usually use in a like real life setup. But then I was quite happy with the strengths. So yeah, strong connectors and really weak boards. So if you need to find a bit of a balance when you use the materials in combination. Then I basically made final designs of 4 connector types. That's basically the one that I showed before. And based on that I could make basically the other shapes that you need to build up all the different kinds of furniture. The last one is not really a connector, it's just a plug, basically for the looks, to make it look nice. So that's what I have for now. But I think in the future it might be possible to just scale them up if you want to build bigger furniture that's even more stable, or you can also maybe change the angles, maybe make something with 90-degree angles, and then you have more possibilities. I think it's quite easy to adapt now. The design goes pretty fast. A few minutes in the CAD program, and then put it on the CNC machine, and you're good to go. Yeah, and then based on those connectors and some boards I bought, I was assembling this example prototype of the bookshelf. I mean, you can see it up in the office. I think it looks quite nice, and it was quite stable, so I'm pretty satisfied. So everything alright then? Yeah, is it really? There's always a but. So then we come to the ethical discussion. I will keep this short. So first of all, the product is definitely more eco-friendly than the original model system with the aluminum connectors. So this is of course positive. But what with like third-party producers? I mean, it's quite easy once it's basically published the product. It's quite easy for anyone else to reproduce it. Maybe also like in large scale in, I don't know, some third world countries, and then you have maybe the risk of child work or that the workers who work on the machines are exploited, or that endangered wood species are used, so then you don't really have so much control about it, about the whole product. But I think if the product is marketed in a way that the eco-friendliness is really like put as one of the main features, then yeah, maybe people will not buy like a similar product that doesn't have those features. And then there is of course the question of rip-off from that I did maybe from the original model system, because as you see with those connectors, they look quite similar to the original product. But then I did a lot of engineering and I just didn't copy it. I made many concepts and tried really different concepts, but at the end I came, this one showed to be the best. And if you have a connection concept like this, then this is kind of like the logical shape you end up with. It's like, if you want to invent the wheel, it will be round. If you try to invent it again, it will not suddenly be like a triangle. So, it's a bit tricky, but I think if I acknowledge that the original idea is not mine, then I think I'm safe and also I have no problems from an ethical point of view. Okay, now I think it's time to summarize everything a bit and draw some conclusions. So first conclusion is, I think the whole product looks quite appealing, even though I used rather cheap boards, for those components. It's rather cheap plywood, but it still looks nice, and I think all people who saw it agree. So I think that's positive. It's stable. As you see, I could sit on it, and also Ole sat on it as well. At the same time,
solid.
I think it was actually more stable than expected, because the dimensions I used now was more like to make like a bookshelf with not like super high loads. But even despite that, it was still stable enough that I could sit on it, and it was no problem to hold our weight. And it's really flexible with the different kinds of materials, wood-based materials and surface finishes you can use. You can have more standard wooden appearance. You can maybe stain it in different colors, or use different types of material or colors for the horizontal boards in comparison to those more vertical boards. You have all kinds of possibilities, I think. Those are just a few, and those are not really the crazy ones. And of course, just from the geometry, you can build up many different things with those connectors. Then the final question, is it really affordable? I think it is, but it depends a bit. Because the setup that I have now, I think it can be produced quite cheap. But you can also use, if you want to have a premium product, you can use much more expensive wood species, and then it becomes much more expensive. And also the question is it cheaper than the original models system? And I think that also depends on the production scale. I think for small scale production, the wood-based solution is definitely cheaper, but once it reaches really high scale, if the product may become successful, who knows? And also the original model system becomes really successful, then they can produce it quite fast with the aluminum connectors, and then it's a bit hard to say which variant is cheaper. So we will see, but I think I can certainly say that it will not be more expensive or significantly more expensive than the original model system. But I think it's definitely affordable. That's about it. Thank you very much.